Hi everyone, welcome to Salesforce Apex Hours. My name is Johannes Fischer, and today I'm going to talk about logging in Salesforce with RFLIB. Just a bit about myself. I started my career out as a software engineer working for a product company building soft phone applications. Those are the tools that are used by contact center agents to answer and manage phone calls and interactions. I eventually got introduced to the Salesforce ecosystem by integrating that softphone application into Salesforce, building a CTI adapter. Later on in my career, I moved over to pure Salesforce AppExchange product development using Apex, Visualforce, and JavaScript. And eventually, I switched over to the consulting side, which is still what I'm doing today, helping our customers to get the most out of Salesforce. I'm a developer at heart, which is the reason why I built RFLIB. First of all, I still like coding and enjoy doing that in my free time, but also to give back to the community, which I have benefited from so many times over the years, either through other open source projects or through code snippets and tutorials and all sorts of information that is available online. Now, if you look at this picture, that was me like over 10 years ago when I started out my career. When I joined my company, my first company, and worked on the soft phone product, I was not only responsible for building new features, but also to help support the applications when a bug report came in. Our app was an on-premise application. It was installed in our customers' network environments because the nature of softphone applications is that they need to be really high performant and require low latency. And cloud applications were not as developed at the time then, so it was just the best design to have them right at the source or really close to the agents and the phone switches. But with this setup automatically came additional challenges, especially when we were dealing with any kind of bug reports and trying to support our app. We only had a ticket with a short problem description and then a log file attached to it when a bug was reported by any of our clients. And with that, these were the only information that we had. So we needed to kind of like create a picture of what was going on within our application, what was the state of it at the time when the problem occurred for the agent. Unfortunately, our log files were not really descriptive. So it was really difficult for us to figure out what exactly was going on, what kind of steps the agent took before the problem occurred, and what was the overall state of the application. This led to us like requiring quite a significant amount of time to debug almost any issue. Instead of like maybe just using hours, it took us days. And this was all time that was taken away from actual product development. Not only was it painful for me as an individual, but they had a real business impact as well. Now, we were lucky enough that about a couple years into my career, our company was offered the opportunity to build a new softphone product from scratch. We changed the design around and decided like a lot of the functionality we want to move away from the server side right onto the client because JavaScript was evolved enough now to actually support such an architecture. But with that came like another challenge, and that is like, okay, how are we going to get visibility of our application, not just on the server side, but especially also in JavaScript in the browser. We had already decided to make logging a first-class citizen of our app based on our experience with the previous application and the struggles that we had there. But now we needed to figure out how we expose that kind of concept onto the client side. We eventually ended up building a logging framework in JavaScript that would report everything that was going on back to the server and merge these information together with the log statements on the server side. This gave us like an enormous amount of information for every time when a bug was reported and the log files were attached. We had a clear picture of what was happening within the application, could track the button clicks of the users, or kind of like based on the information that we had in the logs, have a really good understanding of what the UI should look like. This not only allowed us to debug any kind of issues that were coming up a lot faster than it used to take us in the past, but also to really debug very complicated problems. one of the highlights that I still like to quote when I talk about this is that because of our logging framework, we were able to prove a packet loss in the network layer of one of our clients. It was because we were logging the messages that were sent from the server out to a browser, and also when the browser received the messages, and we had that all in our log files combined. We eventually were able to prove that certain messages were actually not making it to the client. And our customer, who initially really resisted to the idea that the network could be evolved, eventually started looking at their environment a little bit closer and found out that some of the switches during peak hours were dropping packets. Now, what is RFLIB? Well, RFLIB combines the experiences that I made in those early years of my career with the best practices that I developed while working on the Salesforce platform for over a decade. Much of my development style is influenced by the Advanced Apex programming book by Dan Appelman, which I can only recommend for everyone to read. The idea of the library is to serve as a solid foundation, to have really good clean code and a solid foundation that allows you to create your business logic, cleanly separate it, and eventually create transparency into your app that you will need later on when debugging any kind of issues unsupported. At the core, the library consists currently of 3 features. There's a logging framework, a feature switch framework, and a trigger framework. And each of these are actually bundled into their own package. Now, when you hear this, you're probably going to think, well, logging frameworks and trigger frameworks, they are already out there in the market and exist today. I'm using some in my own orgs. And you know what? You are right. There are some really good implementations already out there. But when I was looking for open source libraries that I wanted to use in pretty much all of my projects, I still found that there were some gaps, and eventually decided that I wanted to close those gaps by building my own libraries, my own code base. Now, feature switches, I haven't found anything until today, but doesn't mean it doesn't exist. But at least there's not a lot of offerings in the market. Now, I mentioned gaps. So what were those gaps in the market? Well, for once, my consulting career allowed me to really see and experience that many companies are still not really embracing logging as much as they should. Some had no logging at all. Others were certainly not using it to their full potential. So there was still a place for a new framework to come in that would maybe encourage people to jump on the bandwagon and start to add more logging into their applications. For the existing frameworks, the other problem that I saw was that there are many good frameworks out there, but they're all working in isolation. So you have a logging framework and you have a trigger framework. That is great, but what if you wanted to add logging to your trigger framework? Well, you would have to change the code, which would either complicate any kind of upgrade path in the future, or it might not even be possible because the open source framework is shipped as a package and you cannot modify it. Then the other issue is that a lot of the frameworks, they really are focusing on Apex. But as you've seen over the last few years, Salesforce has really improved Lightning Web Components and the Aura framework, which allowed customers to move more and more of their business logic into the front end. Excuse me. We even have complete components that use Lightning Data Service to interact with the data in Salesforce that allows them to build sophisticated functionality without even touching a single line of Apex code. So if you wanted to support that, Apex debugs logs were not cutting it anymore. And now we talked about, Apex and JavaScript, but also Salesforce heavily invested into their declarative tools over the last few years. And one of the primary features of that is Flow. So when you look at flow and the development that has been done, especially over the last few releases, there's a lot more business logic that will move out of Apex over into flows. But that doesn't mean that you don't need the logging and the transparency anymore. So these are all the kind of problems that were there that RFLIB is trying to solve. Now let's get into the weeds a little bit and start with logging. Logging is all about creating the transparency in your work. You want to create a picture, right, that shows everything that was going on at a certain point in time, and allow your operational team, admins and developers to get that picture, ideally without having to interact with the users, because that usually complicates things. Now, how do you do that? I first want to talk a little bit about some guiding principles that I use in my projects, and that's just because logging is a bit of an art. There is no right or wrong, but there are things that you can do to get more out of it, or at least the most out of it. One of the things that I do in my project is that I cover every code branch. So I see logging as a form of an enriched stack trace that doesn't just allow me to log every method that is being invoked by the application during runtime, but also like trace the path of branches within your code. So all the if statements, switch statements, and so on. As I'm doing this, I still want to kind of like reduce the number of log statements. And I know this is kind of like sounds weird since I just said like be generous with your logging and use it in every code branch, which is still what you want to do. But what I avoid is creating too many log statements in a row, meaning you see here on the screen like an example of a logger info statement in one of the functions of my Lightning Web component. And now, like I could have created another statement here, but because the code is so small and I have the state information here, I know exactly what path the code took pending this statement, right? If the page index is bigger than 1, I know it goes in here. If not, it just passed it. So I didn't have to create a log statement in here. Other examples are that I've seen people using multiple log statement in multiple lines of code. So like this statement here, this message would be broken up into 2 log statements. First one says navigate to the previous page, and then the second one would give me the printout of the page variable. Well, both of those things are not great because we're dealing with Salesforce, which is a cloud platform that has a lot of governor limits. And because of that, we need to be really cautious with our resources, and that applies for the logging framework just as much as for anything else in your application. There are some other reasons which we'll get into just in a few minutes. But last thing that I want to point out here is that, and that's often overlooked, using the right logging levels is important. Especially when you're using RFLIB, my recommendation is to use the info log level as a standard for most of your log statements. And then as you, for instance, log within a loop, or you have some really big log statements that you want to print out, move those ones to debug or trace level. Whereas any kind of problem areas that you identify within your code base, you then have warning, error, and fatal log statements in order to differentiate between those. Okie dokes. So what are the key differentiators that RFLIB brings to the table? Well, I want to repeat, good logging frameworks exist today. But the beauty of innovation is that to learn from those ones and make things better. So in RFLIB's case, like one of my highlight features is that it fully supports Lightning Web Components in Aura. You can now have logging in your hands, a logging framework at your hands that you can deploy within your JavaScript business logic, and that will actually report back to the server side and make it visible to your admins and your developers for reviews, and that allows you to avoid like having to always connect with your users in order to figure out what's going on. Some of the existing frameworks, they already are very sophisticated, but they are kind of like reporting every log statement individually. And there's a disadvantage to that, like, because whether you use platform events or you write those log statements to a custom object as a record, like stitching those multiple records together, especially in an environment where multiple users are logging at the same time, is extremely complicated and takes a lot of time and effort. So you're losing some of the benefit of the logging if you only have actually really one single line log statement available to process, and for the others you need to spend a lot of time to find them within the amount of data that is being created. Logging is something that kind of works on a more general level, but you always have situations where behavior of it has to change and work differently, and that's where those custom settings are coming into the picture. There's a rich set of configurations that you can apply on a global level, but through the hierarchical custom settings also then override on an individual level, which is especially handy when like one user or a small group of users are reporting any issues that you need to really dive into and monitor more closely. There's a number of utility classes that you can use that help you reduce boilerplate code. And then, as I mentioned during the gap analysis, we're also dealing with Flow and Process Builder as a kind of programming language to build sophisticated business logic in your Salesforce applications. And RFLIB comes with actions, custom actions for those tools that allow you to do logging right out of those tools in a declarative way. So here are the settings that are provided by the library. I want to point out the stack size first, which are here the client log size and the log size, which is for server, and the browser, two individual settings. So the log stack is basically the collection of log statements that are being written to the framework before a reporting event occurred. And when those statements are being reported, it basically takes the entire stack and then sends that over to the server to create a platform event out of it. So this is really handy because not will you process one message, but maybe in the context of an Apex transaction, you will have one log event that contains the entire log stack with all the log statements that were printed within the transaction. And on the browser side, you get a significant amount of information of the user session that was recorded prior to the event that eventually caused messages to be published. So when do you publish messages? Well, that is depending on the actual reporting log level that we're seeing here set to warning as default. Again, there's a setting for the client side and for the server side. And this means that whenever there's a log statement printed in warning, error, or fatal level, and a platform event will be created with the full log stack information and information about the client that encountered this issue. Also, you can change these settings, so you can set it either lower to info or higher levels such as like error instead. RFLIB still supports all the native platform logging frameworks, which means the Apex debug logs and the browser console. But you can still decide what messages you actually want to print to those two frameworks. And that is specifically handy on the browser side, where you can go in and set, for instance, the client console log level instead of debug to none, which means that no messages will be logged to the console, which is very handy in a production environment where your users might be bored and start looking at what's going on in my application, and then they won't see anything. But that doesn't mean that the logging is turned off, because that still happens behind the scenes, and any kind of reports that are being created, they are still containing all the information. We have an email log level, which allows you to decide when any log events that were reported are eventually being converted into an email to notify a user base. This is very handy for like a fatal or error statements that you eventually want to send out to a group of users to alert them that there's something going on in your application. And last, there's the logger factory class. So RFLIB comes with dependency injection. That means that you can actually fully override the entire implementation for the interfaces it is using to run its logging engine. So as you have the loggers being used in your business logic and use the out-of-the-box framework classes to do logging, at some point you may decide, hey, I need my own implementation of this. Well, what you're going to do is you just copy out those example classes that I created and then start changing them or overriding the code or logic. And then all you need to do is, once you've done that for the default logger factory and the default logger, you switch the name out here in the setting to use your own classes without having to touch any of your business logic at all. This is really handy as well if you want to continue to update RFLIB and get the latest features, because you can just upgrade the packages, get the latest features. It still uses your custom implementation, or if you later on decide like you want to revert back to the out-of-the-box classes, well, all you have to do is changing one setting in your code. All right, so we talked a little about the high-level pieces from RFLIB. Now we're diving right into the code, and we're starting with Apex. So when you're writing logs when you want to start logging in your Apex classes, the way I do it is by defining a logger instance right on the top of your class. I'm using the RFLIB logger util get factory method, because by using that, you will actually retrieve that value from the custom setting for the dependency injection that I just mentioned. And then you call the create logger function with a string that is called the context name. And what that does, it separates the different logger instances, and you will actually see that reflected in the logs that are being reported, and makes it very easy to identify a component that where the issue was reported from. I personally always use the class names as my context name, but it's a free string, so you can add in there whatever you like. Now, as I said, in functions, we're looking here at an action controller function. I typically log at the beginning of the method, like that the method was invoked. And so here we have an info statement being logged, and we see the log message with placeholders in there. This makes it easier to create a log message without a convoluted string concatenations, while still being able to easily inject the values of certain variables of your application at the time. You see more log statements here, a warning, a fatal statement that was added when an exception was being caught. So here you just see how to do the different log levels. There's one more concept shown in here, and that is the concept of the log timer, which is kind of like an additional utility. You can start a timer, for instance, at the beginning of your method, and that will track how long the execution of the method took. So whenever you call the log timer.done, it will actually look at the duration since the start and then go and compare it to a threshold that you define at the beginning. If the duration is larger than a threshold, then it will log this message that is defined here as a warning to your logs. And depending on your reporting level, this may eventually then be reported onto the dashboard. By seeing those warning messages of the log timer popping up, you may notice performance issues in your application. That is very handy, for instance, when you're dealing with HTTP callouts and web service requests, where you have an SLA that the web service should respond within 1 second. And if that doesn't happen, you get a warning printed to your log, and you can actually identify during what peak times that slowness occurred. Now, moving on to Aura. When you build your custom components, you first want to add the RFLIB logger component to within your custom component. It needs an ID. By convention, I would highly recommend to leave logger as the standard ID in any of your components. Then it has the same like Apex, a context name that you define. And last, there is a very specific attribute that only exists in Aura, and that's the append component ID one. Well, append component ID, when it's set to true, will actually take the Aura framework's unique component ID and attach it to the context name. When you have, for example, like a custom input component that you edit to a form multiple times, this will allow you that all the messages produced by one instance of that component to be easily identifiable and distinguish themselves from the other instances within the same page. Now, in all of our controller and helper functions, we first want to find the logger component, which is basically our logger instance, and then we can start logging as you see it here. Very similarly to Apex, we have the log message first, including placeholder syntax, and then an array of the values that we eventually want to inject into the message. Moving on to Lightning Web Components, things look a little bit different there. The way how we instantiate a logger is by importing the factory method from the RFLIB logger module, and then invoking the factory method with a context name, and creating an instance of our logger usually at the top of the module. And then you just use the logger the same way how you're doing it in Aura, by just including the log statements into your JavaScript methods. One small difference though is you don't have to combine the additional arguments that are going to be injected into the placeholders. Using an array, you just basically chain the arguments as additional parameters on the method call. Okay, and so when I started out building RFLIB, the first thing I had was the email handler. And when I started using it as part of projects, I noticed very quickly that, well, this is creating a lot of spam. So I got messages sent, especially through some bigger debugging scenarios where there was a lot of messages being created. There were sometimes 50 or 100 emails that I got within minutes. And obviously that was just not the right way of doing it. So based on some existing frameworks in the market that already had like a similar dashboard component, I got inspired to do the same for RFLIB. And the log monitor allows you to monitor real-time and historic events from within this dashboard. Platform events are generally cached on the platform for 72 hours. So this is the duration for how long they are visible in here. And then you can just browse them by looking at the different list items here, page through the number of log events that you have received, search for them and filter, which is really important, and then eventually look at the details on the right-hand side. You can also download the full log file into a text file very easily with just a button click. Now let's see all those things in action. For my demo, I used the Salesforce Dreamhouse application and then started adding RFLIB to it and built the log statements into the components and Apex classes the way how I would do it during when I do any kind of production work. And then I added like 3 kind of failure scenarios into the app that we are going to review today together. The first issue is going to be a validation error during a DML operation. The second issue is going to be an error in an Apex action controller, and we're seeing how it's being handled between client and server side. And the last issue is the most complex one. In that case, we don't actually have an error, but we have unexpected results of our application. And I'll show you how you would go about this in using a debugging session with your client to get more details about the problem that was going on there and track down the root cause of the problem. And with that, I'm going to switch over to our Dreamhouse application. As some of you may already know, like the people who have already used the Dreamhouse application may already know that it comes with a set of sample data that you first need to import using the sample data import component. Now, when I click on this button, you will see that the import failed because of an error. So how would I find out what's going on here? Well, let's open up the RFLIB log monitor, which doesn't work here. So let's do a quick refresh. And of course, I'm having internet issues. Okay, it almost feels like presenting at a conference when you run into internet issues right at your demo. Well, I sorted out mine, and let's continue with the Dreamhouse example. So just to recap, we were just producing this error, and we wanted to see how we can debug this issue. I'm going to open up the Ops Center, which is RFLIB's library that contains the log monitor dashboard. And then in here, you see when it's finished loading, you see the plain dashboard without any messages. I'm going to put this here on the right and then the application over onto the left so that you can see the interactivity of the framework in real time. So I'm going to reproduce the problem here, recreating the error. And you see within a couple seconds, the error message appeared on the right-hand side in the dashboard. I'm going to maximize that. And let's have a look at what we have, what details we can see. Just on the list view itself, we have the timestamp of the problem, the user ID for the user that experienced the issue, the Salesforce request ID that allows you to link the RFLIB log to an Apex debug log, or even messages in the event monitoring. The level that caused the message to be reported, and then last, the context string, which we talked about earlier when we went through the code samples. Now, when I click on this, we see some of the details repeated here, but for the user, you notice that there's not a user ID, but the information has been translated into actual user information. So RFLIB behind the scenes takes the user ID and resolves the username, email, and phone number for you, which is really handy because it is very much possible with this framework to detect problems before your users maybe even notice or at least report them. So you can reach out to them and get right at the bottom of this while it's still fresh in their mind and not at the end of the day when they're starting to remember what happened at around 2 o'clock. Now then we see the log messages here. As I mentioned earlier, thanks to the log stack, this is not just a single message, but like everything that happened in this transaction on the server side. It starts out with the invocation of the import sample data function, and then eventually at the very end of it, we will see the error that occurred. In this case, we're dealing with a custom validation exception that says your property is too old to be listed, and then have the stack trace that even corresponds to the error. Well, this just reminded me that I did create, let's put this back on the right-hand side and bring back the application here. I did create a validation rule that would prevent any kind of properties from being added during the runtime of the application that are older than 15 days old. So let's take a look at that one. And we see here's the rule about the age of the property, but we also see something on the top here that refers to one of the feature switches that I also created within the application. Now, give me a moment here. Now, let's take a look at that feature switch. It says here data load is in progress, and you got to imagine like the value that this feature switch can bring if you're not only using it in one individual validation rule, but maybe in several dozens. So if you're actually doing a data load and you need to deactivate a number of validation rules, all you have to do is go in to the feature switch, which is custom metadata here, and we see the data load in progress feature switch listed at the bottom. Go to edit, and in our case, activate the switch, save, in order to make this validation rule not fire anymore, and in our case, the data load to succeed. Perfect. So just to recap, we saw an error on an Apex side, controller side. We saw how we were able to easily identify the root cause of the problem and eventually drive into action. Now let's go on to scenario number 2. In our second scenario, we're dealing with the DreamBot component. If you haven't used this before, it's kind of like a little assistant that has a number of commands available that users can use to interact with the Salesforce platform and get some data and other actions done. So if I type in the help command, I see like the out-of-the-box commands that it supports. So I'm just going to pick one here, which is 3 bedrooms in Boston. Print that out. Great, I'm going to get all the properties listed that are located in Boston. Now, what happens if I print something in that maybe the bot doesn't understand? And before I do this, I go back here and clear out the log file so that you see the interactivity of the application. I'm hitting enter, and boom, we are seeing 2 log statements being printed. Number 1 is the log statement from the actual OR component, and number 2 is the correspondent log event that contains all the messages of the controller side, like in Apex. And this is perfect because now you can really put the two together in order to figure out what happened on the client side and the server side in order to create a full picture of the environment at the time when the problem occurred. Now here on the server side, if I go down, I very easily figure out that, hey, no handler was found for the command. And if I look a little bit further up, I can see that the submit function with foobar was invoked. Now, what would that look in the client side? Going right at the bottom here first, we're seeing that how the submit button, like submit call was being made out to the server with the foobar string, and then how the server responded with a message saying that, oops, something went wrong when this command was invoked. But if we're looking at the history that happened beforehand, we're not only seeing that, okay, foobar was the last message that was entered, but we also see everything that happened before. So when we started like using the application, we see first some details around using the sample data importer. Eventually we keyed in the word help, pressed enter. Later on, we copied into the string for the 3 bedrooms and then just hit enter. In this case, we noticed that there was no individual key presses that happened. So we can make that assumption until we eventually ended up at our foobar scenario. So you see the richness of the information that is being collected by the logging framework at runtime and then used when any kind of problems occur in the reporting mechanism. Very, very valuable. So this was our second scenario. Now let's dive into the last example. And that is, let's clear the logs again and go here to the right. Back to our application, the data problem where the application functions fine, but we're having an underlying issue. If I'm going to the property finder and define filter criteria for a search, let's take 3 bedrooms and 4 bathrooms, which means that all the listings should include at the very least 3 bedrooms and 4 bathrooms in order to appear in the result screen. But as we're going through this list, we're seeing listings here that actually have 3 bathrooms listed. So how can this happen? Let's have a look quickly at our log dashboard. Nothing was being reported. So this is one of those scenarios when we actually have to interact with the user. And I'm an admin right now. I got the ticket from the user saying like, hey, you know what? Like, I think your property filter is not working right. I say, okay, let's dig into this a little bit deeper. Let me make some changes in the configuration settings. So I'm going to the logger settings right now and making some changes on a global level, but in a production scenario, what I would do is I would go in and make those changes as an override for this particular client. And I'm saying that on the client server side, I want to report every info statement to the server. I'm going to save this now. Go back to my property finder. I have to refresh in order for any kind of configuration changes to take effect. And then I will start reproduce the issue. But what we're going to do here is, again, we're looking at the log monitor and what happens there. You can see that by just loading the page, we already got 13 log events reported. And if I start using now the filter, you can see how the number on the right-hand side changes. We're still having our bad results, but we captured about 45 log events that capture anything that was going on in the application for this user at the time. Now in here, if I'm going through the context, I see, hey, there's a property filters component. That sounds like the one that is dealing with like this search tile on the left-hand side. And then in here, obviously, anything that was the most recent is at the end, so I scroll down to the bottom. What I'm seeing here first is that 2 things. There was a filter change event that contained, hey, the number of bedrooms are 3 and the number of bathrooms are 4. That actually matches what the user told us. But then when we're looking a little bit further and see a call to get properties on the server side, we are looking at the parameters that we are provided, but look at this. The number of bedrooms is 4 and the number of bathrooms is 3. So this doesn't match up. Let's have a look at what happens in our code base. And for that, I'm going to copy out one of our strings of the log statement, because that string is static. It makes it a very easy target to find in all of our code files in order to navigate our application. So here's the single statement in our code base that actually prints out this message. And if I'm looking right here, then I see the action parameters are just defined above. And looking at the bedroom, I can see there's a mix-up in the values from the component attributes and the parameters that are being sent out. So what I'm going to do is, let's cancel that out. I'm going to just replace that on the bedroom side, and I'm going to replace it on the bathroom side of things, make it match up, and save. Now we just have to wait a few seconds for the changes to be pushed to the Scratch org. And then we should be able to confirm that our code is now working. So let's give it another moment. All right. There we go. Perfect. So we don't need the log monitor anymore for now. We solved our issue. And if we're looking here, refreshing our property finder, and then re-executing our search, we have no more properties with 4 bathrooms, and we can now confidently say that the problem has been fixed. So these 3 scenarios just kind of should give you an idea about the kind of support you're getting by the framework in your day-to-day operations. Obviously, those were demo scenarios, but I think or at least I hope that they are resonating with you based on your own experience and the type of support that you have to give for your users. Now let's look at some of the other features of our application, or of the RFLIB framework, and that is the feature switches that are coming next. So for any features that I'm building in our application in RFLIB, like my focus is always on building an experience for the developers and the admins alike. For the feature switch framework, that means that everything is fully configurable using the custom metadata that we saw earlier in the demo. This means that you can actually use proper deployments in order to set your feature switch values and make it part of your continuous integration environment. But what you lose with custom metadata is the benefit of the hierarchical custom settings that Salesforce provides out of the box. So in order to not miss out on that, because feature switches most definitely have a good use case to be very selective, I created actually a hierarchical structure into the custom metadata configuration. So you can create feature switch values on a global level, on a profile level, as well as on an individual user level that allows you to have different settings being applied to different users and do, for instance, A/B testing or like a staggered rollout of functionality between your groups. The feature switch framework has support for Apex and the front end side of things. So Aura and LWC have both support through library modules that allow you to access the feature switch values with very little code. And then, of course, it supports like the declarative side as well, and here namely flow. You have custom flow action that allows you to go in and look at the feature switch values, including the hierarchical resolution, and then make decisions based on the feature switch values in your flow logic, and have that kind of like sophisticated business logic in your flows. Here you just see some of the examples. We are looking at feature switches being used in Lightning Web Components, in Aura. We used it in validation rules or any kind of formulas, and then here at the bottom on the flow side, and then of course last but not least in Apex. All right, let's go to the trigger framework. Just like with the feature switch framework, it tries to create an experience for developers and admins. Though obviously there's a little bit more for the developers here because we're dealing with triggers. The real benefit of the trigger framework is that it's fully decoupled. That means every Salesforce trigger is a one-liner. And then the handlers behind the trigger and the event are actually instantiated dynamically, very similarly to the dependency injection that we saw for the logging framework. This really has the benefit of simplifying your unit testing. Not only become all your trigger tests like pretty much a standard logic that you just copy and paste for every trigger, but you can also fully isolate every trigger handler and unit test without the others being in the picture, because the framework has some specific test functions in place that allows you to define what handlers should be invoked in what order. It uses custom metadata to fully configure the behavior, and we'll just see that in a second. And then it's fully transparent because of the dependency to the logging framework. Logging is built into the trigger framework, and it actually includes a lot of diagnostic information. So if you have any issues that are happening during a trigger execution, you know exactly what handlers were being invoked, in what order, and so forth. So here's an example of an individual trigger, and I want to point you on the right-hand side here, where you define obviously the event under which the trigger should be executed, and then you can define in which order the handlers that are all listening for the same object and event are being executed. All of this is pretty standard, but what is relatively new and I haven't seen before is like the exception behavior configuration value. There are two options here. Option number one is to abort a transaction. That's kind of the default behavior, what Apex does anyways. So if you have an error thrown that is not caught in your trigger handler, then eventually it bubbles up and the entire transaction is aborted and rolled back. Now with RFLIB, you can have a behavior that allows you to continue the execution. If you, for example, have 3 triggers on your count object for an after insert trigger event, and they are all doing atomic tasks, meaning they are not depending on one another, and one of them throws an exception, well, there's a good reason that the other 2 should still succeed in what they're doing, and that's exactly when this option comes into play. And because RFLIB's trigger framework already uses logging, you would still see a log event for the error that was caught and being reported in the framework, but then the other 2 triggers succeeded, and when you actually debug or support the issue of the trigger failure, you only may have to make data corrections for the one trigger that failed. Now, after going all of this, I want to close with a couple more stories that show the value of the framework as a whole, specifically on the logging side. There are 2 stories. Number one, I was working on a CRM transformation project that where our customer went from their legacy CRM to Salesforce. After about 9 to 10 months of work, we had go live where on a Friday afternoon, the client's users logged out of their old CRM, and then eventually on Monday morning came back to work and started using Salesforce. You can imagine that working until the last minute, having a big data migration exercise happening over the weekend, that when the users returned on Monday, not everything was working perfectly. We obviously had errors, and there were over 200 errors reported through the framework during the first workday. But because of the level of diagnostic information that we had and the good practices we applied to our customizations in Apex, we were able to group all those 200 errors into less than 10 categories, some of which were data errors, others were functional issues that we needed to fix. Through this mechanism, we were able to reduce the number of errors from a daily basis from over 200 to under 50 within 48 hours. So by the end of Wednesday, we were below 50 errors, and most of them were only bad data related. So with the framework, we were able to, again, instill trust into our ability to support the application that we created with our customer. We were able to bring the customer back within like the first 3 days to their productivity levels that they had when they left the old CRM. And then after fixing another few issues, they were able to use the new developments and integrations that we created and increase their productivity within the first 3 weeks to levels that started where they could start and really collect the returns of their investment. Now, the second example is the full development cycle where RFLIB was used for a heavy front-end customization of a Salesforce community. Developers use the framework like using the console forwarding of the messages to develop not only their log statements, but also like see as they were writing their code that everything was working. But we used the framework in UAT during our sprints to identify the issues that the testers discovered during the UAT testing. And in some cases, like we were able to even respond to them before they filed the ticket in our ticket system and tell them that, hey, maybe this was a data issue, or just that, I already started working on the fix. On average, from a UAT testing cycle perspective and fix perspective, we reduced the effort from on average 30 minutes to investigate any problems in UAT, in most cases to less than 5 minutes. And not only that, the framework allowed us to identify a very complex race condition for force record data invocations that happened very quickly, one after another during load testing, where the second call actually was executed on the server side before the first one and created some invalid data. So what happened there is we were able to see that the race condition happened. We were able to prove that the order was wrong in the way how things were executed, and eventually then take corrective actions on the client side to make sure that we serialize the execution of those save requests. And last, as we rolled out all the functionality into production, we still were able, thanks to the framework, to identify some production issues that were caused by untested data scenarios and very quickly fix them as well. Needless to say that also here the customer was very satisfied because we prevented a lot of issues from actually making it into production. And then we're able to fix any kind of issues that we found shortly after go live in an absolute minimal amount of time. So how do you get started? Well, take a look at the repository. The link here is at the bottom, and maybe consider installing the packages in a Scratch org or in one of your developer sandboxes, and then start logging in your business logic and add log statements to your code. If you need some help figuring out on how to do it, I spent a lot of time working on documentation and created quite a bit of examples and how-tos in the repository's wiki and in the README page. So check those out, and obviously feel always free to contact me and let me know if you have any questions. And then really just start developing. Use the library. I hope you will like it. And let me know what you think. I'm very happy to hear any kind of feedback, good or bad. And with that, I wanted to thank you all for listening to my presentation. If there's only one thing that I want you to walk away with today, is that logging is really, really important, and I would encourage all of you to do it. Whether you use RFLIB for your logging framework or just Apex debug logs or another framework, that really doesn't matter. But like, in order to get the most out of the Salesforce platform and build like really good customizations and applications for your users and customers alike, I think logging is a very, very important part of that. Feel free to reach out to me. You see here my Twitter handle and my LinkedIn contact information. More than happy to connect. Or check out my blog, where I once in a while always write a few articles either about Salesforce or sometimes also about other cloud platforms. And with that, I wanted to thank Apex Hours again for giving me the opportunity to present today. I hope you all enjoyed enjoyed this presentation and I got your interest in RFLIB. Thank you very much again for listening, and have a great rest of your day.